Today we are going to start by exploring some triangles and finding some relationships. But before we do this, let's quickly review some knowledge students would already know at this point. This triangle is called a right triangle because one angle is exactly 90 degrees. So without a protractor, we can look and see that this is a 90-degree angle because if we take a Post-it note, a corner is 90 degrees and it fits right into that angle there. So this is a right triangle. The next type of triangle we can have is called an obtuse triangle. To be an obtuse triangle, one of the angles must be greater than 90 degrees. So just by looking at it, we can see that this one looks more than 90 degrees, and if we're not sure, we could take our Post-it note and line it up with the bottom side here, and you can see that this angle goes out of this 90-degree angle, so it is greater than 90 degrees. And then the last type of triangle we can have is called an acute triangle. And an acute triangle means all angles are less than 90 degrees. So all of these angles look less than 90 degrees. If we weren't sure, again, we would line it up with one of the sides of the triangle. And you can see that this side right here goes inside the 90 degree. So it is less than 90 degrees. Each of you received 3 squares. After this video is over, you will take your squares and lay the pieces out so that it forms a triangle without any overlap. So you'll take your 3 squares, everyone has a different color, and you're going to move the pieces around such that each of these squares, this length right here represents a length of a triangle. So you have to use this whole entire side. So in other words, you cannot do this. You cannot form a triangle. There's a triangle inside here. That would not work because we need to go from the end of the side. So you're going to go ahead and move the pieces around so that they fit to form a triangle like this. Once you have formed your triangle, then let's go ahead and look at the handout that you were given. Given 3 lengths of a triangle, let A and B represent the length of the shorter sides, and let C represent the lengths of the larger side of the triangle. So you're going to go ahead and take the triangle that you just formed, and you're going to label your pieces A and B if they're the shorter sides. A, and this is B, and then C is the longest side. So as you can see that this forms a triangle, and the length of this triangle right here is the length of this square right here, which is 1, 2, 3, 4. And this one is 1, 2, 3, 4, 5, 6, 7. And this one is 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we have a triangle with these 3 side lengths, 4, 7, and 9. Then we are asked to find the area of the 2 smaller squares. So to find the area of a square, we're going to take the side length, which is 4, and 4 times 4, 4 to the second power, is 16. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there are 16 squares here, so 4 to the second power. So we're going to go ahead and repeat that with side B. So 7 times 7 is 49. And then it asks us to sum the area of the two smaller squares, so we're going to add these together and get 65. And then compare the areas in column 2 and column 4. Well, I need column 4 in order to compare, so I'm going to move on to column 4. The area of the larger square, so this had a side length of 9, so 9 times 9, the area of this square is 81. So comparing these two numbers, column 4's area is greater than the sum of these. Okay, then we are asked, is the triangle acute, right, or obtuse? So to me, these both clearly are acute. This angle right here looks obtuse to me, but if I'm not real sure, I can take a corner of a piece of paper and I can line it up with one of the sides of the triangle. And as you can see, that this angle here has more than 90. So we would classify this as an obtuse triangle.